Today's video will demonstrate how to identify redundancy in a class design problem and then reduce it. Hello, I'm James Helfrich. Redundancy is the bane of the existence of programmers, because if we have more than one copy of code, then fixing a bug one place will not fix it everywhere, and then the code falls out of sync. This video will demonstrate how to identify redundancy in a program and how to reduce it and even eliminate it. Inheritance redundancy is the extent to which common elements exist in an inheritance tree, and there are several different levels. For an example, distinct, which means there's no duplicate attributes or actions. Minor means any duplication of attributes or functionality is actually far apart in the inheritance tree. Critical, which means the siblings have common attributes or operations, and redundant, which means that there's lots of redundancy. Clearly, we don't want to have critical or redundant. Okay, let's see how this is going to be done. Can we reduce redundancy in a chess program? Now, my chess program is going to have a board, and the board is going to have a piece, and they're related by association. But what kind of association? It's composition. And how many pieces are on a chessboard? Well, the chessboard is 8 by 8, so that's going to be 64. Now, one type of piece is a space, and the space is related to the piece by inheritance. But we're also going to have a pawn, a knight, a bishop, a rook, a queen, and a king, and all those are different types of pieces. Now, each piece is going to have a position by association. And what association is going to be, once again, composition, because the piece will create and destroy its position, its location on the chessboard. And there'll be exactly one. We're also going to have a move, and this is going to describe how a piece can move across the board. And a pawn, a knight, a bishop, a rook, a queen, and a king are all going to be able to generate a move or a collection of moves describing how they can move across the chessboard. Now, notice each of these pieces does not have a move by composition or aggregation, but rather will return a move or a collection of move by association. A move itself is going to consist of two positions. Now let's dive into that piece a little bit more. The piece is going to have a position. It's going to reference the board as an input parameter, and it's also going to generate a collection of move. So let's see if there's any redundancy issues with the code and see if we can improve it. Okay, we'll start by taking a look at our piece class. Now our piece class is going to have a pure virtual function called getMoves. It's going to take a moves as a parameter and a board. And when I go into each individual implementation, for an example, my king, I will implement getMoves, and it's going to go looking up left, up right, right, down right, and so on. And then we took a look at our queen, and it's going to do the same thing, except it's going to slide. And then we take a look at our rook, and it's going to do, the same thing. It's going to slide. This slide code looks identical. I think we have some critical redundancy. Let's see if we can fix that. Okay, so now I've done this work for the bishop and for the rook and for the queen. They all use get move slide. All the redundant code is missing. Excellent. Now, when I scroll down, however, I notice this move for a non-sliding piece, like a knight, looks a lot like the code that I had for the king that also had a non-sliding piece. This code looks almost like, well, it's identical. So what I need to do is also remove that redundancy by moving that functionality up into the base class. And I'll do that now. Okay, now that I've removed the redundant code between the king and the knight, now my last step is to make sure that there's nothing left. Let's see here. I have sliding and I have castling. That's unique to a king. Okay. The queen, there's nothing unique about the queen. She slides. The rook just slides. The knight is a non-slider. Got that covered. The bishop just slides. Okay. The pawn, well, pawn is different. Let's just put it that way. So none of this stuff is going to be in other code. So I think I'm finished. Let's run the program and let's see how it goes. Excellent, all my unit tests pass. You can learn more about this in the Design Out Redundancy section of the Redundancy chapter of the Software Design textbook.